So next one in line is Manuel Arenaz. He's the CEO, CTO at Codee. And he is going to talk how to modernize Fortran development workflows in HPC with Codee. Thank you so much.
Thank you. OK. Thank you very much for the nice presentation. It's really a pleasure to be here again in Barcelona. I visited many times, but first time attending this event, so it's really a good moment to share and connect with new people. So really, really thank you to the organizers for the invitation. Today I'm going to talk about what is needed in the tool chain, in the tools available for developers to really have everything they need to implement modern Fortran software development processes in the organizations. Maybe you can ask the question, why Fortran? Fortran is one of those languages that is powering mission-critical applications all around the world, from nuclear simulations, astrophysics, many, many things that are simulated in big supercomputers have been written in Fortran. And there is legacy Fortran code that was written decades ago that today developers need to maintain, update, and incorporate new features or develop new features. So in the end, developers that use the Fortran programming language have the same issues that C++ developers have or developers using other languages. So the question is, can we provide them with the modern toolset that they need to really implement modern software development processes? And this is what I'm going to talk about. And this is the main challenge or problem that we are trying to address in Codee. How many of you in the audience have heard about Codee before today? OK. How many of you? I saw very nice and great presentations that helped me learn a lot about system administrations, containers, all these great tools for system administrators. But how many of you here actually develop code on a daily basis, on a weekly basis? Are developers? A few percentage. And how many of you write code in Fortran or have written code in Fortran? 1, 2, 3, 4. OK, quite a good number. So maybe this is, I would say, something different that you might not expect. But I will try to explain you why it is worth developing this type of tools like Codee to help the community that is working with Fortran to have the same developer experience that C++ developers have today. OK? And this is what we're going to talk about. So essentially, what is needed to have a modern software development process using Fortran? In Fortran, as in C++ or any other languages, developers are continuously under pressure to deliver new features for yesterday, features that cannot fail, features that need to be tested for correctness, for performance, for portability across different systems or different programming environments. So typically, similar situations or challenges that C++ developers have. So here I just have tried to enumerate 3, 4, 5 of them. So adherence to modern standards. Fortran is a live language. Fortran is evolving. Fortran is producing or introducing new features in the language. Compilers are evolving to support all those features that are specified and documented by the Fortran Standardization Committee. So in the end, Fortran is evolving. Developers need tools that evolve and that help them to make an efficient usage of the latest features of the languages. So adherence to modern Fortran standards is one of the key requirements that Fortran developers have. Second, and aligned with this, you cannot use a programming language if essentially you don't have compilers, debuggers, IDEs, SDKs, linkers that provide you everything you need to translate source code into binary or executable code. And also, you depend and you rely on third-party libraries that you typically don't develop yourself, but you integrate in your software project. So in the end, your software project is the code that you develop yourself and you maintain with your team. And also, all the third-party libraries that you incorporate, that you link or compile to build your application. So usage of latest tools and libraries is also a hard requirement. Fortran started as C, let's say, many years ago, being a procedural language. So you could develop code writing subroutines, procedures, functions, use whatever name you think you feel more comfortable with. But as projects grow in size, you need to address issues related to modularization of the source code. Otherwise, it has a huge penalty in organizations that need to maintain, that code, developers change from the organization, new developers need to be aware of the organization and structure of the code. So Fortran programming language is evolving to help with encapsulation, modularization, object-oriented programming, similar to the evolution of C and C++. So nothing new in this regard. Something also very important, collaboration. Many years ago, we used to develop code in our laptops, we coded ourselves, and that's it. We created backup copies, just copying the files in the file system, and that's it. But today, modern software development process, you need to implement DevOps best practices to allow for continuous integration, continuous delivery of the applications, and also you need to collaborate with other developers worldwide. So DevOps, control version systems, CI/CD, containers, all of that is also part of the modern Fortran software development process. And with all of this, which is similar to C and C++ or other languages, we cannot forget the code is not valid if it is not correct. So how can we ensure or find bugs as soon as possible in the software development process? A bug that goes in production, detecting that and delivering a new version that fixes the bug to the customer costs 10 to 100 times more than finding the bug while you are writing the code and fixing it right away before releasing the software to the customer. So correctness is mandatory. And for that, in C++, you have sanitizers, you have static analyzers, focus on correctness, focus on functional safety, focus on security, which is something that there used to be no such tools in the Fortran space. Portability. Here we talk about, we had this morning this great CERN VMFS, I hope I said it correctly, that essentially is trying to provide you with the same and homogeneous environment so that you can forget about portability of different libraries or compiling your code for different platforms. You have an homogeneous view of the system and you work on it. But Fortran developers, C++ developers need to care about portability and moving from one compiler to another or cross-compiling code. And something really, really new in Fortran that has been in place in C and C++ for more than 2 decades, but it's new in Fortran, is security. When you talk about Fortran and security, people say, why Fortran security? Is this really needed? Think of any workload implemented in Fortran C and C++ that is running in a system. And it's running simulations that last for days. And these systems are increasingly exposed to internet or cloud environments, even inside the organization, outside the organization. So from the point of view of a chief security officer of an organization, having Fortran code running on that type of infrastructure is a risk for the organization. Developers typically don't care about it, but security managers really care about reducing the possibility of any security risk being found in the organization and coming from any single line of code written in any single language. Okay? So security in Fortran is relatively new. We were requested to support security in Codee in Atlanta, so only 6 months ago. But here we will be talking about cybersecurity regulations, concepts like SAST, SCA, or DevSecOps. Okay? That is incorporating in modern software development process also security best practices from the first moment that we write source code written in any programming language. So, as many of you, it's the first time that you hear about Codee, so we are focusing on Fortran because we know that for C and C++, this type of tools already exist. So we know or we believe that we can complement this and make this state-of-the-art in C++ improve, but we know we have identified this lack of tools in Fortran, so we want to help this community to really have all the tools they need to produce modern software, to implement modern software development best practices. So this is why you see this focus on Fortran in Codee, but we support also C and C++. So what are we providing that you cannot typically find in Fortran? Source code formatting. I will tell you why we have developed in 4 months a source code formatter from scratch. Static analysis, which is essentially the capability of a tool to automatically scan the source code without the intervention of the developer and triggering, pinpointing parts or points in the code where there are potential problems related to portability, correctness, performance, security, modernization, any different types of problems that we will address in a few minutes. AutoFixes. This is completely new in static analyzers. The capability of the technology and the product, whenever you identify a problem, to actually just by running a command, implementing the solution in the source code so the developer just has to recompile and pass all the regression tests that they have as part of the software development process. So formatting, static analysis, plus AutoFixes. And this is intended not only to help developers. We have reports for developers, for team leaders, for managers, for security officers, the same information needs to be presented in a completely different way, depending on who is going to digest this information. This is the report's capability. And from day one, Codee is designed to be installed on-prem, on major HPC systems, and also to be integrated in CI/CD systems. Any continuous integration environment that you can think of, you can integrate Codee in it. So let me start with the formatter. I want to highlight that this was developed in 6 months only. And here you can see kind of a comparison of existing formatters that are available for free. And the requirement that we had in Atlanta from some of our customers was, we need a really excellent code formatter for Fortran that behaves at the same level as Clang format for C and C++. This was the requirement. So we work on a specification of a set of features. We identify which of the existing tools actually support or not support these features. And we said, OK, let's produce Codee format so that it supports every single feature that is needed, that is available typically in Clang format for C and C++. And the good thing is that Codee is a commercial product, but the formatter is for free. You can simply go to this link, download it, and tell your colleagues to start using it. It is free, and it will be free. We just want to provide that entry level to the Codee environment to the Fortran community. The second thing is, key component to remember is the Codee analyzer. Codee analyzer is the static analyzer that is today the more advanced static analyzer for Fortran. That also supports C and C++ because big packages like the ones mentioned this morning, Quantum Expresso, Wharf, and many others, like the ones you can see here, are a mixture, are mainly written in Fortran, but they also have key components written in C and C++ for interoperability with the I/O, with the operating system. There are different reasons why these big Fortran packages have C and C++ code. And here you can see us in minutes or in seconds, depending on the project size and the complexity of the code itself. Codee can find hundreds to thousands of issues, analyzing thousands of loops and functions for the developers. Okay? Imagine this amount of information presented to the developer or to the software development team. The static analyzer is not free. This is commercial software, but we have pricing plans so that you can start with just one single user working with Codee on the laptop, all the way up to collaborative distributed environments that with hundreds of developers collaborating using the Codee analyzer and the Codee formatter. And important, here we are talking many times about bundling software to be pre-compiled and distributed in an environment. So static analyzers must be used for application software, but also for the system software. Imagine OpenBlast. This was a project with one of our customers, and they said, what happens if we pass OpenBlast through Codee? And we found that Codee found 32,000 issues related to modernization, portability, security, correctness, performance in OpenBlast's latest GitHub repository. So what this means is that in order to secure and have good environments, we need to develop good, high-quality Fortran code at the system-level software as well as the application-level software. And this is the presentation that you see, what we call the screening report of Codee. I will show you, I hope I have time enough for a quick demo to show you Codee in action. But here what you can see is that 32,000 issues organized in a ranking, so that as a developer, the suggestion is to start with the top of the ranking because this is pointing you to correctness issues. Recommendation 79 is correctness issues. The code is incorrect, and this was overlooked by the developers. Okay, so this is a great tool, a great technology to help developers to increase the quality of the code. Okay, so think of Codee as a complement to the existing programming environments from major vendors for GNU, LLVM, Cray, Intel, AMD, NVIDIA. All of them are providing you typically with compilers. Codee is not a compiler. Libraries. Codee is not a library. Sanitizers, IDEs, debuggers. Codee is none of that. Codee is complementary to that. So it is providing you static analyzers specialized in Fortran that can find a variety of issues, a formatter for Fortran, for C++, just use the Clang format, which is open source and available there. And also for security, we are implementing today this SAST, Static Application Security Testing reports, and SCA, software composition analysis reports that are related to find security issues in the code that you are responsible for maintaining. And SCA, software composition analysis, about finding issues in the third-party open source libraries that you use in your application, but you don't maintain and you don't code. But you're responsible of it if you are delivering a software, an executable, that is developed using those libraries. Okay? So these SAST and SCA concepts are very well known in embedded software development. So people writing C and C++ code for our laptops, routers, devices sent to the space, all of these best practices for security have been implemented for more than 2 decades in embedded C and C++ software development. So we want to bring all that technology, knowledge, and best practices to the Fortran community using Codee. Very briefly, what are some of our users saying? This is public in our website. Some people really say that there is some kind of overlapping in the features with some sanitizers, with what some compilers can detect when you enable the highest warning level, but still, detections of Codee are unique and extremely valuable and not detected by any other tool. Others, like Veselin, he was using Codee in the context of AI development tools. And he said, I'm using Codee to format the code produced by AI, to standardize the style, how it is written, and also to validate the correctness of the code produced by the generative AI, which is a huge emerging problem with the generative AI. And with this, is his words, he saved 25x times the time that it would take him to do the same job manually without Codee. So clearly, a deep impact in productivity. And finally, this was the last one is, I had the opportunity to be in person in this presentation by Michael Singale, where they are developing code and they said, bugs happen and will always happen, no matter how good your software development process is. You need tools like static analysis tools that are really, really good. So if we have that for C and C++, then we need that for Fortran and we need to adopt it. Okay? I'm coming to the end of this first part of the presentation. So what are the purposes that you can use Codee for? Of course, we are talking about high-performance computing. So everybody starts asking, can I use Codee for optimization and speed up the speed or the execution time of my Fortran or C++ code? Can I use Codee for that? The answer is yes. But before considering that, you should always consider in a mandatory way finding issues and fixing issues related to correctness. No discussion about that. Modernization. If you want to offload code to a GPU, you will need to write the code in such a way that is, let's say, amenable for CUDA, amenable for OpenMP offload directives, and this requires writing the code in a specific way. So modernizing the code, portability issues reported by Codee help you to prepare the code so that it is ready to start adding to your code, offloading pragmas or offloading directives. This has been tested by our customers in the US for more than 3-4 years. And finally, security as well. So here you have many specific examples of use cases where our users are using Codee. For security, I think I will go very quickly on that, but I want to motivate it because I think it's a growing problem that we need to be aware of. Why Fortran today? As I started in my presentation, Fortran is powering critical infrastructures today. And Fortran, C, C++, no matter the language where you write the code in, you need to implement DevSecOps best practices starting in the source code and how you write it to minimize the probability of security issues to appear. Second, infrastructures are increasingly exposed to the internet. CERN grid technologies that started some decades ago, now we have distributed environments where the software is running in a distributed manner all around the world. This is exposing the workloads to potential security threats. An important thing is security is starting to be a requirement in regulated markets. In the US, we have the NIST SP 800-210 from 2022 that is mandatory. Many organizations writing C, C++ Fortran code need to be compliant with the requirements for security in the US. In Europe, very recently, some months ago, the Cyber Resilience Act brings to Europe similar requirements that they have in the US. So in the end, organizations must and are increasingly asked to adopt security best practices even in Fortran C, C++ code. And security starts in the source code, not only in the infrastructure, not only potential network attacks. So you need to reduce the risk and be familiar with these concepts. Just one example. For security, there are decades of catalogs of coding best practices that C++ developers need to be complied with. And many of them, as you can see here, are programming language agnostic. So that means that if you write Fortran and you are required to write secure Fortran, you also need to comply with CWE 900, whatever it means. Okay? So what you need is tools that essentially can find occurrences of these CWEs or SACRC, different coding standards that have been written for programming languages. You need to find instances of these issues that have been well documented in your source code. And as a developer, you should definitely invest time in securing your Fortran C++ source code. So here what we are doing at this moment is mapping all the more than 90 checkers that Codee has automated in the recent years to see a subset of them that really is aligned with the requirements for secure coding in Fortran, C, and C++. And with that in mind, we can produce SAST reports for security in Fortran. So if you are interested in any of these topics, in January, we have started to produce in collaboration with people from the community. Brad Richardson is very well known in Fortran, part of the Fortran Standardization Committee. Recently, Fabiano Lima comes from embedded software development and security. He's now collaborating with us. So you can see that we have 30 minutes webinars specialized in different topics that can be important at different moments for your software development process. So if you want to see live demos of Codee producing reports specifically designed to address these problems, you can watch these webinars. So before coming to the conclusions, I'm going to do a very short live demo. The first thing I would like to highlight is we are aware of the importance of having public online documentation about Codee. So everything you do or you can do with Codee, you can go to docscodee.com online, and here you can see, for instance, how to start using Codee, how to install it from the beginning, or what are the steps that you can just copy and paste these commands in a Linux terminal, and you will be able to reproduce all of these situations. We have also a lot of documentation that we are adding every week with integrations of Codee Analyzer with the major editors, with the major control version systems, with the major CI environments, and also the same thing for the formatter, with even a playground where you can play online with it. But the more important thing is, I think, all of these integrations, because for developers, for a good developer user experience, you need to provide them a tool that integrates with everything that is part of the development process. And finally, FAQ, the changelog, where you can see that mostly, ideally every 2 weeks, we produce a new release of Codee, minor release that is just announced here, and every term we do a public announcement with major new features that are expected to have high impact on the community. And also we are increasingly adding information on how to use, for instance, Codee in the scope of Microsoft Azure, if that is the platform of choice in your organization, or in the HP Cray system. So we can add here Lenovo, Dell, whatever environment is valid or valuable for our users. So let me do a very, very quick demo. This is my MacBook Pro with a terminal. This is a Docker container that I'm going to run with Codee pre-installed, so I can see with Codee -- version. The Codee, we are not implementing the Fortran program or C++ front ends. We are leveraging the LLVM technology for that. But apart from that, we are providing integrations or support with the major open source or third-party libraries that are using Fortran packages, as well as integrations with all the major compiler suites that you can think of. I just want you to see one run of Codee. I think I don't have time for more than that. So Imenu is a simple project. So here you can go to the quick start guide, copy the commands. I'm going to go down to this single command so that you can see that in order for a static analyzer to provide a good user experience, need to be integrated even with developer build tools. So here we can see that CMake provides built-in support to produce compilation databases. This is a set of entries where every single file that is part of your build, with the exact compilation command that you invoke to make the build, all this information is injected into Codee for Codee to run the analysis. So the next step is just running Codee. I'm going to go directly to this last step. Codee checks. You can copy and paste the commands from the website. You can see Codee in action, where it has essentially scanned all the files in the project and produced what we call here the Codee checks report. Let me focus on one single, I think it's 69, verbose. We repeat the analysis, and we can see all the details about every single check that are collected by Codee. And let me just run the AutoFix. That is the capability of Codee to actually fix the issue that was found and documented in the Open Catalog. And with Git diff, we can see what Codee has done. It has replaced the usage of modules by making explicit the usage of only the variables that are used from that particular module in a particular subroutine. This is part of the encapsulation or part of the data scoping process that every developer should do. Okay? So here we have seen just a single run of Codee, how to use the AutoFixes using the command line interface. For the sake of time, I'm going to go back to the presentation and just 1 minute to finish. So what have we seen here? Fortran developers need similar tools that exist for C and C++. This is the main motivation for us in Codee. Here we can see that Codee enhances the programming environment. It's not a replacement. It's an enhancement and complementary to all the tools that you are already using. And it must talk to it. And finally, consider formatting, very important from the beginning, static analysis with different purposes, and just have in your mind one thread watching security issues, even for Fortran, C and C++, because this is coming as something mandatory due to regulations, even to HPC. And that's it. Thank you.
Okay, we have time for a couple of questions. So just to convince you a little bit more on this. So Archer, the supercomputing facility, it's publishing statistics about what is the most popular programming language used in the HPC, in that supercomputer. And 70% of the core hours go into actual Fortran code. So most of the time when I talk about this, and people that have been there for quite a significant time, so Fortran is not the most popular one on the new generation, but the reality is that there are a lot of very big packages, software packages that are still using Fortran, and those are dominating the HPC. Any questions? No? Okay, so we are going to, thank you so much.
Thank you.